Hello, ladies and gentlemen. Today we're going to be looking at how to determine whether a function is odd, even, or neither algebraically. Let's get right to it. First, with the definition again of what an odd and even function is. An odd function is one that if you negate the x value of the function, the y value is also negated. We can represent this as points by saying for every xy that exists, the opposite of x and the opposite of y exists as well. It's a reflection about the origin. For even functions, if you negate x, your y value ends up being the same. Again, what that means is that for every xy coordinate there is, the opposite of x and y also exists. So how do we test to see if a function is even or odd algebraically? Well, we're going to end up substituting in the opposite of x for every function and seeing what that does to the function. Alright, so let's take a look at our first function, which is x squared plus 5. If we negate the x, so we're going to substitute in a negative x. Whenever you use substitution, always use parentheses. We end up with something that looks like this. So if we have the opposite of x squared, that will end up just giving me x squared. The opposite of x times the opposite of x, the negative and the negative would become a positive, and x times x is x squared. And then we still have the plus 5. So notice that my function remained, f of a negative x is exactly the same as f of x. So my y value, f of x, remains completely unchanged when substituting in the opposite of x. That makes this function an even function. Okay? Let's look at g of x equals x cubed. Okay, so if we negate, or we substitute in a negative x, we're going to get negative x cubed, or the opposite of x cubed. If we cube a negative number, like negative 2 cubed, we get negative 8. So we can rewrite that as negative x cubed, or the opposite of x cubed, rather. Okay, so what happened to my function? My function is not exactly the same. Is it completely the opposite? Well, let's take a look. The opposite of g of x would equal the opposite of x cubed, which is indeed what we got. We got the opposite of x cubed. So because my negating x also changed my y values to be the exact opposite of what they used to be, this function is an odd function. Alright, let's look at h of x as 1 divided by x. If I negate my x, I'm going to substitute in the opposite of x. I end up getting 1 over the opposite of x. Okay, I can rewrite that if I wanted to as the opposite of 1 over x. So notice it's not the same as h of x, so we can immediately eliminate the idea that it's even. But this looks like it's the complete opposite of my h of x. Let's just do a quick check. It shouldn't take too long. Equals the opposite of 1 over x. And sure enough, that's exactly what it looks like is happening. My value that I ended up getting by negating x ends up being the complete opposite of the y value, or h of x. So, because my y values are all the opposite by making my x values the opposite, this is an odd function. Alright, let's take a look at j of x. I'm going to substitute in the opposite of x into this quadratic. We did a quadratic earlier, x squared plus 5. It ended up being even. Let's see what happens here. Alright, we're going to substitute in opposite of x squared minus 3 times the opposite of x. Alright, opposite of x squared, we've learned that one before. It'd be 2x squared, and the negative 3 times negative x would give me a positive 3x. Alright, so let's compare this to this. So it's not exactly the same, because up here was 2x squared minus 3x. This is 2x squared plus 3x. We can eliminate it being even then, because it's not exactly the same function. Is it the opposite of j of x? Well, let's see. If we were to substitute, or we were to take the opposite of the entire function, what would we end up getting? We'd end up getting negative 2x squared plus 3x, which is not what we ended up getting when we substituted in negative x. Okay, so it's not the same as j of x, nor is it the opposite of j of x. It's somewhere in the middle. Well, that means it's not even or odd. It's neither even nor odd. Alrighty, let's take a look at k of x, which is an absolute value problem. What happens if we negate x? Well, because we're negating x and x is solely on the inside of an absolute value function, we would expect that it would give us the exact same thing. Because when you take the absolute value of a negative number, it becomes positive. So, lo and behold, when we negate x, k of x is unchanged. It's exactly the same. So, because my y values remain unchanged, we can say that 2 times the absolute value of x plus 3 is an even function. Negating x does not affect the y value. And let's look at our last example, this linear function, 3x plus 20. So if we take and substitute in negative x for all of the x's, we'll end up getting 3 times the opposite of x plus 20, which when we multiply that out gives me negative 3x plus 20. All right, it's definitely not the same as above, so we can eliminate the idea that it's even. Is it odd? Well, let's see. If we were to take the opposite of m of x, this would be negative 3x plus 20. And when we distribute the negative, we'd get negative 3x minus 20, which is not what we got by negating x. So by negating x, we got neither m of x, nor did we get the opposite of m of x, which means that this is neither even nor odd. So hopefully you have a good idea of now how to test to see if your functions are either even or odd or neither.